folks, we're going to talk a little bit more about binomial probabilities today. Okay, remember that means we want to have exactly two outcomes showing up, anything we can classify into two, and then we have to make sure that, remember, there's a set number of trials and each trial is independent from the last one, or the probability does not change. Okay, so flipping a coin, probability doesn't change. True or false, probability doesn't change, things like that. Okay, so what I'm going to have you do is just answer questions 1 and just 2A based on what we talked about last time and just sample spaces in general. And then we're going to talk about something just a little bit different today. So after that, you can come back to the video to check those. Okay, remember, because each coin flip has two options, heads or tails, and they're independent, we can do 2 to the third to get 8 total outcomes we're looking for. Please try to stay organized when you're listing these. So I went all the ways to get 3 heads, then all the ways to get 2 heads, and then 1 head, and then no heads at all. Okay, you don't have to necessarily focus on heads, but if you group them together that way, it'll help make sure you don't miss any. So with that in mind, the next one was 2 to the 5th is 32. So we're going to talk about probabilities today, and I'm going to compare it a little bit to last time what we did. So last time we were talking about shooting free throws, and we had a sample space that looked pretty similar to this. There were 8 outcomes if we listed them all, but we had miss, 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 and make, 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 and I'm going to compare that to heads, 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 and tails, tails, tails. When we were thinking about last time, Washington was a 72% free throw shooter, which meant this make, make, make was more likely than this miss, miss, miss to happen. In the case of what we're talking about today, right now, heads and tails are equally likely. So this is 0.5, 0.5, 0.5. This one too is 0.5, 0.5, 0.5. Because all of these outcomes are equally likely, we can say each of them counts for a probability of 1 out of 8, and we can calculate things that way. So that's really nice if we have a sample space, but on the next one, we don't have a sample space when we're asked to find how many ways are there to get 3 heads when we are flipping 5 coins. We know that we're out of a total of 32. We just don't know how many ones have exactly 3 heads, because you could have the 3 heads first, or the 3 heads in the middle, or heads, tails, heads, tails, heads. There are a lot of different ways we can do it, and our job is to find out the exact number of ways. Okay, so this is choosing 3 heads from 5 coins, and hopefully you remember that when we're choosing some number of items from a group, but they're the same thing, that's considered a permutation or a combination. And because I don't care where the heads show up, I just need 3 to show up, this is a combination. So to get the top number, we can just take 5C3 and toss that in our calculator. So as a reminder, you put the number first, and then we go to math, over to probability, and we want the third one down, and then we're choosing 3. So this tells us out of our 32 in our sample space, there are 10 outcomes that have 3 heads. And then we reduce it, 5 over 16, or you can write it as the decimal. It's up to you. Okay? So what I want you to do is try C, D, and E for me. Pause the video and take care of that. All right, so at least means 3 or more, because this part C was the same kind of concept. We just find the combinations. But at least 3 means 3, which we already found up here was the 10. Okay, 4, which we already found up here was the 5. And then if we're choosing all 5 heads, there's only one way to do that. You just have them all heads. Okay, so a total of 16 over 32, or 1/2. And I hope that makes sense to you, because when we're talking about flipping a coin 5 times, we have 0 heads, 1 head, 2, 3, 4, or 5. And if we think about those outcomes, okay, 3, 4, or 5 is half of them. Now, it's not this balanced number of each, but it is a symmetric value, and I'm going to get to more detail on what I mean by that here in just a second. Okay, the at least 4 was just the 5 or the 1 to finish up that. Okay, so before I have you do number 3, I'm going to show you something that will kind of help with these combinations. It doesn't take a whole lot to type this in, but there is a way if you're dealing with the same problem. So all of these we're dealing with 5 coins for us to get these values a little faster. Okay, and that's using Pascal's triangle. Okay, so if you have a piece of paper or a note card would even be better. That's what we did in class. Okay, what I want you to do is we're going to talk about Pascal's triangle and how it applies. Okay, so pause the video till you grab that, and then we'll chat it through. So in your note card, the middle of it for the first row that you have, okay, I want you to put the number 1. And then in the next row, you're going to have another 1, so it looks like a triangle of 1s here. Okay, in the third row, we're going to do the same thing, except now that we have middle values, because these were all on the edges, the middle values will be found by adding the 2 digits above it. So 1 and 1 makes 2, and we're still going to end on a 1. Okay, then we're doing it again, starting with a 1, but then middle values will add. 1 plus 2 is 3, then 3, and then end with 1. And 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And I want you to continue that down until this second number is the number 10. Okay, pause the video and do that for me. Okay, so what I want you to do is just check your last row there. If those numbers match, everything else above it is fine. If you have an issue, go ahead and correct that. I'm going to talk about what each of these values mean. So back on your note card, what I want you to do is to the side, okay, start at 0 and then number them all the way down. Okay, so this number that you see here should correspond to your row value all the way to 10. And this is the n value. So all of these numbers on Pascal's triangle represent combinations with the n value that is associated with their row. Okay, so going back to this problem, when we were dealing with flipping a coin 5 times, this row is the number that would correspond to it. So I'm going to copy those numbers on this 1, 5, 10, 10, 5, 1, and we'll talk about what these mean. Okay, so just like we talked about here, there were 6 really options. You'll notice there are 6 values here. This first one represents 5, choose all 5. This is 5, choose 4, 5, choose 3, 5, choose 2, choosing 1, and choosing none. I have you start at 5 so that you don't forget 0, because a lot of people want to count 1, 2, 3, 4, 5, and then they run out of values. Okay, if you start with the highest number, you won't do that. But it is symmetric, so it technically doesn't matter whether you start with all 5 or whether you start at 0. But now, if I want at least 3, I know this is 5, 4, 3, it's these ones, and I just take that 1, 5, and 10 and add them up. Okay, and this works anytime you need a combination. Now I had you go to 10 rows because that's a practical number. Anything after 10, it's really just as fast to type in the combination. But again, the purpose of this is to speed it up when you're answering multiple questions about the same number of trials. Okay, so what I want you to do is answer questions on number 3, A and B, using Pascal's triangle. Okay, so exactly 3 is this one, because this is choose all 6, 5, 4, 3. Then at least 3 would be that way from that number 20. And then remember, I don't care if you write this as a reduced fraction or a decimal. Just if you have to round, sometimes our fractions don't look like rational numbers. If you have to round, just make sure you're telling me you round with approximately. Okay. Also, this 64, hopefully you just did 2 to the 6, but it is equal to all of these values together. I just think it's faster to use your power when you have that chance. Okay. On number 4, we are looking at the probability of a certain cancer to remain in remission for at least 1 year, and it's giving us that probability is 0.7 for all patients with that cancer. We're going to now find the probability that exactly 2 of the 4 patients being monitored can keep that cancer in remission. So we're going back to a sample space where the outcomes aren't equally likely. Okay, so I've got 4 patients, so I may have remission, 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 and I have not in remission as well. But when we think about these, they're not equally likely because these weren't 50-50. Okay, so this means our sample space is useless to us. We have to use our binomial probability. Okay, remember this is binomial. A lot of times a key word is this word exactly, but it's binomial because we have 2 outcomes. They stay in remission or they don't stay in remission. And we're assuming if they're different patients, those being in remission or not are independent from each other. Okay, and there's a set number of trials because we've got 4 patients exactly that we're working with here. So grab out your note card, and the reminder for that we have NCK, and then times the probability of success to the power of k, however many you want to be successful, and then the second part is just the leftovers. So it's 1 minus p, but we can do that math in our head. And then this one's n minus k, just the leftovers from our total that were left over to, in this case, not have remission. Okay, so setting this up, you can use Pascal's triangle to find this combination if you want, or you can write it out using the formula. A lot of times for this one, I'll still write it out as a combination first because it helps me fill out this part faster. Okay, so my total was 4 people, and I wanted 2 of them to be in remission. So here's what I mean by it helps me fill out the second part. I know I'm going to have 2 probabilities here. The first probability was 0.7, and this is the leftovers, so 0.3 to get to 100%, or the number 1. The first power is 2, because I'm just copying it here. And then this is however many more I need to get to 4, so there are 2 left over to not be in remission. But then you can use Pascal's triangle to find this value if you want, rather than typing it in. Okay, 4 choose 2, here's 4, 3, 2, it's the number 6. So then when you type it in, you don't have to use the combinations, you can just use 6 and then follow with the rest. So the 0.7 we wanted 2 of, and then the 0.3 we wanted 2 of, for a final probability of 0.2646. Okay, now that I've reminded you how that works, I want you to try part B. Pause the video and get that done. Alright, so this one, the 2, was that number we just came up with, and just like we did with our flipping a coin, we're just going to add it to the 3 patients. Okay, remember, OR means add as long as the events are mutually exclusive. We can't have exactly 2 patients be in remission and exactly 3 patients be in remission at the same time. Okay, so for these OR situations, we are going to add. Okay, so we have that number, and then we just add it to the combinations for choosing 3. Again, you can use Pascal's triangle to grab that number rather than typing it in. It is up to you. And then 3 people were in remission and 1 was not, for a final probability of 0.6762. Okay. All right, number 5, I'm going to have you try on your own. Okay, it's another binomial probability. Okay, try that one out and then come back to the video after you have completed it. Okay, when we talk about probability of success, this is literally P from that formula. So it's the probability for 1 single trial. In the last case, it was 1 single human who was in recovery being 0.7. This one is talking about guessing on a test. If there are 4 alternatives, one of those 4 is correct. So the probability in 1 trial of guessing correct is 1 out of 4, or you can write 0.25, it's up to you. Then the leftovers is 3 out of 4 that are wrong, or 0.75. So 6 or more correct would mean 6 or 7 or 8, because that's how many total questions we had. Okay, so for this one, you should have had an 8C6, and then 1/4 to the 6th power. There are 2 left over to get us to that total of 8. Then we're going to do the same thing with 7. So we're choosing 7 now, which means our power changes to 7. And then leftovers is only 1. And then the last one, 8 choose 8 is just 1. There's only one way to grab them all. Okay. But you can grab each of these from Pascal's triangle to save you a little bit of time typing this in. Now with this one, the 3/4 the leftover is 0. If there's nothing left over, you really don't need that piece because remember, anything to the 0 power is 1. When we multiply by 1, it doesn't change anything. Okay, no worries if you type it in because you're going to get the same answer. Okay, but this, you'll notice, takes quite a bit of time to set this up because there were 3 different ones. 2 isn't so bad, but 3 is kind of rough. So I'm going to show you another way to do this using this formula that you see on, it's on your note card, but it's also on this sheet. Okay. When you have 3 or more, because it's tedious, you're allowed to use this shortcut. Okay. This is the sum, because we're adding things, of a binomial probability distribution function. Now, a distribution function assumes that we're running a simulation multiple times, but because we're doing this under the assumption that the trials are independent, it's going to work out for us. And then this n is your total number of trials, p is our probability of success, and these are the items we're talking about that we're adding together. So in the case of that last problem, n was 8 total questions. P is probability of success, which was our 1/4 or our 0.25. And then our values that we're choosing consist of more than one option. It was 6 or 7 or 8. Okay? And so we're going to type this in together. All of the instructions on where to find this are on your note card, okay, so you don't have to memorize the buttons. First part is sum, and it says it's second stat math sum. Okay, so let's do that. Second stat over to math at the top. Sum is the 5th one down. Now we're going to do the binomial PDF. Okay, second vars, it may not actually be A, so make sure you're looking at that it's actually PDF. So second vars, and then you scroll. The PDF for mine is A. Yours may be 0 depending on how many functions are in your calculator. Oops. I'm going to have to redo that. Second vars, and then just grab that one, and then we're ready to fill out the order of those things we just found. Now your screen may not show this. Either way, we're typing these things in the same order. If it doesn't show this screen, you're going to just use the parentheses and the commas you see written on your paper here. Number of trials we decided was 8. Okay, so hit 8. If you see this screen, just go down, but if you don't, you're adding a comma. Comma, remember, is above the 7. Okay. Probability is 0.25 or 1/4, either one. They go down or use a comma. Set brackets can be found above the parenthesis, so hit second parenthesis, and then 6, 7, 8, and close that parenthesis. Then you just hit enter until something pops up. And there is your probability, which should match what you got on the last one using the binomial theorem, setting it up each piece separate. Okay? I'm going to let you use this shortcut anytime you have at least 3 outcomes, like we did here. If we see the word or, that's just 2, and I want you to do it by hand. Okay? So what you're going to do is now answer questions 6 and 7, and then come back to the video to check it. Alright, so this one was exactly 5. So this is a do by hand one. Remember, you can use your Pascal's triangle to get that combination, or just type the whole thing in. That was about 0.3164, telling we rounded. It is required for you to write what you type in your calculator, just like we've been doing all chapter. Okay, that goes for these ones where you're using your shortcut as well. I want you to write out what you're typing in your calculator. So at the very least, you need to show me the N, the P, and what's going in your set brackets, so I know that's what you're doing. And this was very, very likely because our probability of 1 working was 0.92, and at least 3 working is pretty low. We're taking 3, 4, 5, 6, adding all those outcomes. Okay. These ones, okay, you can try if you want to. We didn't actually do these 2 in class. We just checked on this one. Okay, 6 or 7 you have to do by hand. Okay, at least 7 you can use the formula for. Basically, we would need to know you can use the calculator shortcut when you see at least. Okay, but it's 3 or more probabilities. Okay, when you see this word or, you have to do it by hand. And that's it. Okay, please let me know if you have any questions.